This video gives a general overview of the process for installing passive infrared and inductive loop sensors to count cyclists and pedestrians as a component of North Carolina's non-motorized traffic monitoring program. Although not every detail is shown, this video should inform interested agencies on the key steps that occur after sites are selected to install continuous count equipment. There are several configurations of non-motorized counting equipment used in North Carolina's program. Depending on the application, a metal post or wooden post is used to house the infrared sensor. Some applications also utilize a rainbird or sprinkler box. Before any equipment is installed, it is important to have utilities located on and around the site to ensure that the exact placement of the counting equipment does not intrude. This is an example of a site diagram showing where equipment would be installed. Utilities should be marked along this corridor. The first step of installation is to prepare the site. For equipment using a metal post, the conduit and fixing cage must be set in advance to allow enough time for the concrete to cure. Where concrete is used, an extra day in advance of installation may be needed for curing time. For installations with a wooden post, separate holes for the post and rainbird are dug. Appropriate traffic control measures should be set up before installation begins and must consider pedestrian accessibility needs. Depending on the site and traffic control plans, flaggers may need to remain on site throughout the installation process to direct traffic and modify the temporary work zone layout as the installation progresses. Installations on shared use paths should also use appropriate traffic control to alert trail users in advance of the work zone and to divert or stop traffic as needed in compliance with the Americans with Disabilities Act. In the North Carolina program, both pedestrians and cyclists are detected. This image shows an infrared sensor mounted in a post on the left, installed to detect pedestrians, and an inductive loop on the right, which are installed to detect cyclists. An interference tester is used to determine exact loop placement. The post location is selected based on the distance to the inductive loops and an ideal place where the infrared beam can be oriented to detect pedestrians. The loops must be cut to vendor specifications. A template of the loop is drawn in the optimal place in the roadway or path. It is then painted to guide exact location of the pavement cuts. Depending on an agency's capabilities, a contractor or in-house staff may be used to cut the loop to these specifications. The dimensions of the loop and depth of the loop channels are measured and checked during installation. The loop cut is then extended to the curb or edge of the pavement to allow wires to exit the pavement and be routed to the post. Either compressed air or water is used to clean out the loop before wiring begins. The loop must be dry by the time it is sealed. To complete the loops, wires are wrapped around each of the loop channels. When completed, each loop will have 8 turns of wire. Special care is given when wrapping the loop wires to minimize damage as it is turned. Once each loop has been completed with the appropriate number of turns, the wire leads are twisted together until the number of twists per yard is achieved. Wires that are not twisted to specification may not send a proper signal back to the data logger and result in miscounts. The twisted wire is fed through the cut channel back to the post or sprinkler box. The wire is then tested to ensure the loops are functioning properly. Next, the wire is pulled from the saw cuts through the conduit. It is then fed into the rainbird or post, where the wires will be connected to the data logger. The wire is connected to the data logger, ensuring enough extra wire so equipment can be serviced if necessary. All connections are carefully made to ensure each wire is connected to the correct channel and contained within waterproof connections. The posts are set up and secured to ensure the infrared sensor is level, angled perpendicular to the path, and at the correct height to detect pedestrians. Once installation is complete, the units are tested. Cyclists ride over the loops and pedestrians walk in front of the infrared sensor to ensure that the equipment is functioning and logging properly. Once the equipment has been confirmed as functional, the loops are sealed. It is important to use a sealant that will not exceed 140 degrees Fahrenheit, as temperatures above this range will degrade the wires. The sealant is spread until it is flush with the pavement. At this time, the equipment is secured with theft-resistant hardware. Finally, after installation is complete, the site is cleaned of any displaced dirt or debris that may have occurred. Each site is unique, so actual installation processes may vary slightly from those shown in this video. Thank you for viewing the overview to the process for installing continuous count stations as part of North Carolina's non-motorized traffic monitoring program.